Hey guys, welcome back. So in this lesson we'll continue with our previous definition and we're going to reward our views a little bit different. Like I explained in the end of the last lesson, the change when a view hits the preferred landmark, the change is too abrupt. And in this lesson we're going to take a look in how we can generate a transition that's a little bit more gentle. So let's get to it. And we're going to do it here in our definition where we generate our 20 numbers, or 25s. Instead of simply generating 20 numbers with the same value, that's the point where we're going to meddle a little bit with our definition. So first we're going to generate a range of numbers using the range component. And the amount of numbers we're going to generate is again 20. And we need to use a small expression because the range component generates 20 steps, which results in 21 numbers. So if you right-click on the n, hit the expression, and type in x minus 1, which means we get 19 steps, and that in return results in 20 numbers. So that's exactly the amount of numbers we want. Let me move this part a little bit to the top. And also let me move this part a little bit down again, because we need a little bit more space. These parts a little bit to the right. So these numbers, they go from 0 to 1, which is fine. The base domain from 0 to 1, that's fine. But we're going to remap these numbers using the graph mapper. And this is a very nice component that will let you remap a set of numbers using a graph. And there are various presets available. And the one we're going to use is the parabola. So let's connect our numbers. And let me show a panel so we can see the outcome a little bit more clear. Now you need to imagine the parabole representing our 20 mesh faces, and we want the highest number to be in the middle. The middle mesh face is basically the most optimal view a building can have. And if you go to either side of those mesh faces, you're basically rotating a little bit off the preferred view, which we're going to see in a second. I think it becomes a little bit more clear. So we need to adjust this function a little bit better. So this is the middle. And either to both sides, it's going to get less. And as you can see now at the result of the numbers, you see that we go from 0.17 at 0. Then we go up all the way to 1, well, almost 1, when we hit 10. And then it goes down again to 0.18. And that's exactly the kind of redistribution of numbers we want. Now the only thing remaining is to remap these numbers. So instead of going from 0 to 1, they go from 1 to 5. And 1 to 5 because those were the bounds of our normal and preferred view we specified here. So let me use a remap numbers component. These are the values. And a construct domain. So the A is the 1 again, and the B is the 5. Just like that. Let me put these two next to each other, and let me group them. So instead of having here, we have 25s, very simple, very plain. But this one is a little different. It goes from, well, 1.6 all the way up to 5. And then it goes back again all the way to 1.7, depending how you drag these handles from the graph mapper. So instead of plugging in the outcome from the duplicate data, we can insert our remap numbers into here. And let's check out the result. Let me also reorder this one a little bit. So instead of 5, I'm going to use a number that's a little bit lower, just for you to see what happened. So let's use, I don't know, let's say use 3. And let me go to the Rhino canvas. And let me rotate the building again, so you see the result a little bit better. So here, I'm just about to hit the preferred view. And if I rotate slowly, you see that they get increased but by phases. They don't exactly directly get multiplied by 5. That only happens in the middle part. Let me also try to rotate the other buildings away so we only have one building hitting the preferred view, so it's more clear. So here you see the stepping happening. And if I rotate a little bit more, you see that the views increase until I hit the middle. But then if I go over the middle, you see that they decrease again. And that's what I meant with having a transition that's a little bit more gradual. So it's up to you which one you want to use, either the really blunt amount of just inserting 20 multiplication factors or the one where you use the remap value, where you can fine-tune these numbers a little bit better using the graph mapper. I've run the simulation using both, and I found that both methods actually work pretty well. So it's up to you, just play around a little bit with it and see the results for yourself. Also, don't forget that the accuracy also depends on how much mesh faces you're going to turn your preferred view into. Because now I have 20, as you can see in my Rhino canvas, the perspective view. But of course, if you're going to use the blunt way of just duplicating numbers, you don't need 20, you just need 1. Like this, because you don't need an array of numbers. But if you're going to use the remap numbers component with the graph mapper, you need at least a decent amount of numbers. So you can project these numbers properly and the result will be a little bit more accurate. So in the next lesson, we're going to run our simulation using these new inputs. And we're also going to take a look into how we can achieve an even better result by taking a look into exponentially rewarding or penalizing certain outcomes. So thank you so much for watching, and I'll see you in the next lesson.